Alright, 7th grade pre-AP class, we are moving on to similarity transformations. Okay, so we did similar figures. Now we're doing similar transformations. Transformations just means like transformers. They're the same thing, but they transformed. And that's what we're going for. We're going for similar transformations. Alright, first of all, we have to do definitions. So dilation. A dilation just means that the object changed. It either got bigger or smaller, but it's the same shape. So in other words, we take a triangle and we make it smaller. The triangles are the same, but one's just smaller than the other one. So the actual definition is a transformation in which a figure and its image are similar. What it means by image. Image is a new shape. So after a transformation, the new shape is considered an image. Now, scale factor. Scale factor is the ratio of the length in the image to the corresponding side of the original figure. This is what this is saying. How do we get from the original figure to the image, to the new shape? Did we multiply it by 2? Did we divide it by 4? Or something like that. Now, something you have to remember about scale factor is that it's always multiplying. So when we divide, that usually means you're multiplying by a fraction. Keep that in mind. Here's an example. Down here we would have A, B, C, and D. Now, our new object would be A prime, B prime, C prime, and D prime. These are primes, and they're just saying that they're the same point, they're just new after a transformation's happened. So, how did we go from 5 from the original figure, the old shape, to 10, the new one? Well, think about it. 5 times what gives you 10? 2. So the scale factor for this one is 2. Let's try it on the other side. 2 times 2 should give me 4. It works out. And that's what we're studying. We're just studying scale factor, the number from where we get from 2 to 4 or from 5 to 10. Now there's two types of dilations, two types of transformations we're really going for right here. The ones we're going for are reduction and enlargement. Those are the two types of dilations. A reduction means it gets smaller. An enlargement means it gets bigger. Now a little bit more detailed definition about it is right here. A reduction, the scale factor is less than 1. Think about it. Let's say the scale factor is a half. If I do 4 times a half, that gives me 2. It makes the number smaller. So that makes the whole shape a reduction, a smaller shape. When we're enlarging, it has to be the greater than 1. Because when I multiply by 2, it makes the side bigger. Here's an example. In this example, we want to know what the scale factor is and if it's an enlargement or reduction. Well, you should just look at the picture and be able to tell if it's enlargement or reduction. How do we go from the red, A, B, and C, to the green, A prime, B prime, C prime? Does it get bigger or smaller? Well, it gets smaller, so it's a reduction. So we've answered that question. But now we have to figure out what the scale factor is. Well, let's look at these two, 16 and 8. I went from 16 to 8. So this is what it is. It's 16 times something gives me 8. Now we know that x has to be a fraction because it's a reduction. So we have to figure out what that fraction is. Well, it's easy as solving this. How would you solve this normally? Well, you would normally divide by 16 on both sides. And we would get x equals 8 over 16. Now let's reduce that. Ends up being a half. So x is a half. So my scale factor is 1/2, which is less than 1, so it's a reduction. You see how everything's connected? Let's see if it works on the other side. How do I go from 12 to 6? If I multiply 12 by a half, I get half of 12, which is 6. It works out. So we found the scale factor. Let's do another one. Sometimes you're going to be given a graph, and the graphs are a little bit more involved. But so is scale factor. Did you know, and you probably don't, that scale factor not only works for every side of an object, but also works for every number on the object. And it also works for the perimeter of the object. Pretty crazy, huh? So scale factor is used in all those areas. Let me show you what I mean. Let's pretend like our scale factor is 3 over 2. So is this an enlargement or reduction? Is 3 over 2 greater than 1 or less than 1? It's greater than 1. So we're going to have an enlargement. So now we've got to actually figure out what our new shape looks like. So what we're going to do is we're going to take each point from this figure and multiply it by 3 over 2. So watch. L, the point for L, remember x always goes first before y, is 1, 2 for x, and 1 for y. K would be 1, 2, 3, 4 for y, for x. And by the way, those are -4 and -2. Sorry, I messed that up. -2 because we're going to the left, and down 1 for y. So that's -1 for y. Alright, M is 1, 2 for x, positive, and up 1 for y, so that's positive. N would be 1, 2, positive 2 for x, and down 1 for y. So those are our points. Now that we have our points, what we want to do is apply our scale factor to each one of those numbers. That seems a lot. But you're just going to have to do it. You're going to multiply each one of these numbers by 3 over 2. So I'm going to put my new numbers over here. L, K, M, and N. There we go. It's all set up. Now I'm going to multiply each number by 3 over 2. What is -2 times 3 over 2? -2 over 1 times 3 over 2 would be -6 over 2. Top times top, bottom times bottom. Reduce that and you get -3. So my new L for x is -3. Now the y is 1. 1 times 3 over 2 is just 3 over 2. Now I'm going to do -4 times 3 over 2. -4 over 1 times 3 over 2 would be 12, -12 over 2, which is equal to -6. And then negative 1 times 3 over 2 would be negative 3 over 2. In fact, let's go ahead and do all the y's. Since they're all 1s and negative 1s, we can go ahead and fill in the rest of those. And also the 2's down here, we can fill those in because they're 3. Based on this one right here that we did earlier. Alright, now that we have all of our points, our new points, we can draw our new graph. So negative 3 and 3 over 2 would be negative 3, 1, 2, 3. And 3 over 2 is 1.5. So that means I go up 1.5 to right here. So there's my first dot. And that's L prime. Now let's do K prime. K prime is negative 6 and negative 3 over 2. Wow. So that means I go 1, 2, 3, 4, 5, 6. And then negative 3 over 2 would be down 1.5. So about right here. And that's K prime. Now let's do M prime. 3 over 2. So I'm going to go 1, 2, 3. And 3 over 2. So it would be about right here. Should be M prime. And then I would go, let's do N prime. 3 down negative 3 over 2. So about right here. Now that I have my dots planned out, I'm going to connect them, make my new shape. Now we said this was an enlargement earlier. Does the shape in fact get bigger? It does. From the blue one to the pink one, it gets bigger. How much? By 3 over 2 as much. Now this is the crazy part. Watch this. It also works for the sides. How far is it from the original L to the M? Well, it's 1, 2, 3, 4. So this distance is 4. Now, how far is it from the the new L to the M? So from here to here. Well, let's count it. 1, 2, 3, 4, 5, 6. Distance is 6. Now, if we did this right, if I take 4 and multiply it to 3 over 2, I should get 6. Let's check it out. 12 over 2. We reduce that down to 6. It works out. So scale factor not only works for every point when it's on a grid like this, for every point, but it also works on every side. We could do the same thing for Kn and the new K prime and Kn prime. In fact, if you want to, you can pause this and try it out. It works out. Let's go on to another problem. Last one. We want to find out what the scale factor is on this one. It's pretty easy. Let me show you how. We can either do it by sides. So like this side right here from T to R would be 1, 2, 3, 4, 5, 6, 7, 8. And from T prime to R prime would be 2. So I know that 8 times something gives me 2. I know it has to be a fraction because it is a reduction, because it gets smaller. So I solved this for x, so I've divided by 8 on both sides. And I get x is equal to 1/4. And that's it. That's my scale factor. I'm done. Now let's do it a different way. Let's say I didn't want to do the sides. Let's say we had a crazy shape that the sides weren't easy to count. Well, we look at the points. Let's look at T. T is 1, 2, 3, 4, and up 1, 2, 3, 4. T's point is 4, 4. Now let's look at T prime. T prime's point is 1, and up 1. 1 comma 1. Now I keep forgetting these negatives. I don't know why. But they're negatives because I went over to the left. Now how did I get from negative 4 to negative 1? Or how did I get from 4 to 1? You get to figure that out. And this is how you would do it. I went from negative 4 times something gives me negative 1. I divide by negative 4 on both sides. And I get x is equal to negative 1 divided by negative 4 is a positive 1/4. It's the same answer. So I not only can use the sides to figure out what the scale factor is, but I can also use each point. Everything's connected. Now that's the end, but we have a lot more to go over about this because everything's connected. It gets crazier. But that's the end for right now, and we'll work on this in class.